All right. Welcome to the August edition of the Deis Community Meeting. We've got a couple of cool demos today and an update on the Workflow 2.3 release, what's going on with Helm, and then what's on deck for Workflow 2.4. So first, to kick it off, Aaron is going to show us MegaBoom, which is a tool that we built for load testing.
Cool, thanks, Jason. I'm going to share my screen in a second. Can you enable me?
Oh yeah, never forget. All right, go for it.
Cool. There we go. Okay, so before I start typing commands in, I wanted to share a little bit of history here. I'm going to move this down, move this a little bit up. Can everyone see this this okay?
Yeah, that's good.
All right, I'll take that as a yes from everybody. So a little bit of history, as some or most, hopefully people remember, we revamped our logging infrastructure in the last release. And that was, instead of reading directly from the fluentDs that are running on all of the app pods, we had the fluentD instances forward log data to NSQ, which is our queuing infrastructure now. And then our logger daemons would read off of NSQ and then publish that log data. Currently, we're using Redis to publish the log data too. And then when someone runs a Deis logs command, that log data would be pulled, the request would still go to the logger, but the logger in turn would pull the log data from Redis instead of directly from its internal memory buffer. So in order to test all this stuff, we took a pretty iterative approach. Instead of just throwing all of it up there and then seeing if it just kind of generally works in a functional sense, we wanted to see if we were making any improvements to the resiliency and particularly the performance of our logging infrastructure. So we built a bunch of kind of one-off tools, and eventually all that stuff coalesced into this tool called MegaBoom. And then actually it coalesced again into a tool called LogBomb. Now, I'm not going to cover LogBomb today. We might be able to cover that in a future demo. But MegaBoom is kind of the incantation of our HTTP load generation that's kind of grown into a more generally useful tool outside of just testing our logging infrastructure, and more about generating huge amounts of HTTP traffic in order to test our apps. And we thought it might be useful for others to test their apps as well. So let me head on over to the MegaBoom homepage. So it's just, you can see it's at github/deis/megaboom. Let me see what's in the chat here. Yes, Bob Lala's LogBomb. I love it. So MegaBoom, you can see it's kind of an alpha, but the general idea here is that there's a CLI already out there written by somebody else, not at Deis, that generates HTTP load, very similar to Apache Bench if you're familiar. And it's just a CLI that executes load on one node. So you have the limitations of a single node, like file descriptors and things like that. So this project just takes that boom CLI command, packages it up into a Docker image, and then it runs that Docker image in a bunch of pods that are controlled by a Kubernetes job. So if we go down, you can see, obviously, we've kind of tailored this documentation to running MegaBoom on Deis workflow. It makes it pretty easy to run it. And then you can make these curl requests to it. It takes in a big old JSON body where you can specify the number of pods, the number of concurrent requests per pod, the number of total requests per pod, and the endpoint that you want this thing to send all this traffic to, a couple other things. And then, of course, the curl request takes the HTTP address of MegaBoom itself. Now, I'm not going to be crafting these curl requests by hand in this demo. Although this document is up to date, so if you want to craft your own curl request, that's absolutely fine, and go for it. I'm going to be using this makefile target. It takes in many of the same environment variables, except this makefile target assumes that the application we're sending all this HTTP traffic to is also running on the same Deis cluster. And in fact, we have that. So you'll see our Deis apps returns MegaBoom, which is exactly, of course, where the MegaBoom server is running. And then this is the app that I'm going to test. Now, the MegaBoom server has two major components. One is, of course, the HTTP server that responds to these requests that come in and say, hey, I want to run this job with this many requests total, and I want to run it against this endpoint. And then this, the MyTest app on Deis, that's, of course, the server that we want to run stuff against. So let's check out that. We have 10 instances of the MyTest server, and I believe I have this already queued up. So the MyTest server is just an instance of Deis's example Go server. To get this deployed, I just did a Deis pull example, Deis/example Go. And it really just outputs powered by Deis. So nothing too exciting here, but what I want is to run MegaBoom against the server and test to see, A, how well is the server holding up in the face of a large volume of HTTP requests, and B, should I scale up? Should I add more instances of this server? I'll say I want to go from 10 to 20 or something like that. And before I run the test, I also wanted to note that I have our monitoring stack, which is Grafana, up, and it's currently monitoring the Deis router. You can see this has convenient things if you've never seen this before. It's got the CPU usage of the router, response time, status codes, and requests per second. So you can see there's no job running right now. We're going to watch the job activity here. And then we're going to run this convenience make build target called test live. We're going to run it against our Deis cluster. This is the router IP. So if anyone else wants to execute requests against it, have at it. We're going to run it against that app that I mentioned before. We're going to have 100 total pods in the job. We're going to run 100 concurrent requests in each pod. And we're going to run a total number of 1,000 requests in each pod. So let's get that going. The request is done. You can see the job started, 100 desired pods. None of the pods are successful yet. And then let's head over to here, and we can see the request per second particularly. It's now up to, let's see, just over 250. That might be 275 or so. It's going to probably peak out maybe around 400, but I'm not. Yeah, it looks like it's just above 400. And now it's going to go down. It's going to kind of sawtooth as pods come up and then finish. And we can also go over to our NSQ health dashboard. And we can see that the CPU of NSQ is going up, obviously, because it has to handle a lot of these log message coming through. The topic message depth means the depth of the queue. That's log messages coming through the queue. Eventually, this looks like it's going to flatten out, but eventually it obviously should go back down as the logger instances start consuming the messages. And then you can see messages per second here. And all the while this is running, you can see the jobs are starting to finish. All the while, if this is running, we want to make sure, of course, that the logging infrastructure works. You can see Deis logs. And what's happening here is that there are a ton of log messages coming in. So the logger instance takes a while to collate all of those together and then return them. So you can see these are the log messages that are coming in. They're all pretty simple GET requests with no path to the root path. And that is pretty much that. So, of course, it's kind of fun to watch these graphs go up and down and up and down. But what we're really looking for is that none of these lines just go up uncontrollably. They don't just get out of control because, for example, in this case, one of the loggers failed. If we go back to the router, close this up, we don't have response times that are spiking into like the hundreds or tens of seconds. We don't have a bunch of failure codes. Requests per second isn't going through the roof because we want our router, of course, to be able to respond fairly quickly. So let me hop over to the chat, see what's going on here. Boom. Yes, Ken's asking to show the Redis dashboard too. I can certainly show that. over to here. And before I start into this, MegaBoom, yes. This is the Redis status. This is the monitoring and metrics that we have on Redis. So you can see total amount of memory that Redis is holding. The operations per second in Redis is very important because we don't want operations per second to go out of control on Redis, because that means that there's going to be a lot of contention on the data that we're trying to write to Redis. Similarly, we don't want CPU to get out of control for Redis, because the more CPU Redis uses, the slower in general the response times will be. So in short, that's MegaBoom. I showed a very, very specific usage of MegaBoom, and that was to test our own logging infrastructure. But you can run the exact same command. It's either a curl command, which I didn't show, or a makefile test target, which I did show. And you can literally just generate load on any app. The makefile target, if you'll note, that only generates load on a Deis deployed application inside of the same cluster. But with that curl command that I showed here, you can make MegaBoom execute HTTP requests against any server under the sun. I wouldn't do it on something like Google or something like that, because you're going to get rate limited at best. But if you have a server that you're trying to test, you can do it fairly conveniently with MegaBoom. So that's it. I'm going to stop sharing here, and I'm going to open it up for questions. Let's see. So if anyone has any questions, feel free to ask now. Otherwise, I'll send it over to the next demo. Okay, cool. I think the next demo we're going to do is Helgi.
Yeah. All right, so I'm going to talk about deployments, or show them off more like it. Let's see if I can actually share my screen. Can everyone see that? Cool. So currently, Deis basically just uses replication controllers to represent your applications. And in the most recent edition, we actually started supporting deployments to allow people to opt into deployments, so to use the power of Kubernetes to manage the workload. And the reason why we did that was that Deis was handling a lot of the deployment logic that otherwise Kubernetes could handle on the server side. So it's a very simple demo. Is it big enough for everyone? Just make sure. Okay, cool. So I have a very simple demo app here, and that's using a very simple replication controller. I have 10 pods deployed. And now I want to actually move that to Kubernetes deployments. So you can just set Deis _ Kubernetes _ deployments to any value. It doesn't really matter. And that basically migrates your application. So the really important thing here to note is that you can do this per application, or you can do this for the whole controller. So the API only uses deployments. So right now I am just doing it per application. And now you can see that there is no replication controller. We have a bunch of pods, and they all now have the fancy template hash names. We have a deployment, and now we also have a replica set. We pretty much changed from replication controllers to deployments. We can do other things very simply, just to show that that continues on. Setting more environment variables, causing more deployments. And now you can see that we're actually moving the deployment forward, where we want 10 pods. There are actually 13 in rotation, and 3 of the new ones are up to date thus far. And what's happening there is that you can actually say how many pods in parallel you want to deploy. And by default, we just go based on the nodes. So for example, I have 3 nodes, so 3 pods in parallel will deploy. Now that should be done. This is all very simple, just because it's a similar interface, if not identical, for people. If they're coming from 2.1, 2.0, and are moving to the new deployment objects. The replica set here, this is the original one. This is the new one. So you can still always look at the old replica set if you really want to. And we even went as far as adding in the cause. Oops. I clearly do not remember how to do this one. Okay, I forgot it. But if we do, oops. If we look at this, why is this not working? All right, something's weird. But basically what we're doing, we're...
you were missing your namespace from your command line argument. You have dash namespace, but not equals.
There we go. The demo curse. Those familiar with Deis releases, where we should actually show what's happened, we're plugging that into the Kubernetes change cause as well. And the reason why we're doing that is if you want to use Kubernetes without Deis for certain tasks, just like I want to look at my deployment, I want to see what changed without having to drop into Deis, you can do that still. And it's even to the point where you can actually roll a new deployment, do a new release of something or tweak something outside of Deis. It's not necessarily recommended, as Deis might override it when you drop back into Deis, but these are possibilities, and we're trying to be as Kubernetes native as possible with all of that. But yeah, this is the gist of it. There are a couple of other things, very simplistic. I need to look up the long name of this. You can basically configure how many replica sets you keep. By default, we keep everything. But if for whatever reason you have resource quotas or you just don't want to keep a lot of replica sets knocking around, then you can use this aptly named Kubernetes _deployments_revision_history_limit. This kind of maps to the Kubernetes deployments name. So if we just wanted to have 20 of them, that's totally doable. And that only keeps the 20 most recent revisions around. So that's pretty much it. I'm going to stop sharing. If anyone has any questions or thoughts.
Sweet. Thanks, guys. Appreciate the demos. So I got a couple of updates. We're going to run through, I got an update from the Helm team. So from those folks, they've been working on Alpha 3, and looks like they're on target to cut the Alpha 3 release of Helm next week, which is great because most of the functionality is there and the team is going to be switching over to focus on stability and user experience. And once that's done, we can start to continue efforts on making workflow deployable with Kubernetes Helm. So we're excited about that. There is also a weekly developer call for the Helm team, a standing developer call on every Thursday from 9:30 to 10 a.m. Pacific. So if you want more details about that, the Kubernetes Slack and the Helm channel is where you can find everybody hacking. With respect to workflow 2.3, I just wanted to give a quick release overview. We're in the final stages of testing, and we'll most likely cut the release today. And I've got a blog post that goes over in more detail all of the feature functionality, but I wanted to give everybody a quick highlight for what we've got in 2.3. The first thing up is that we no longer require insecure registry. We have created a new proxy component that will deploy as a daemon set in 2.3. By default, it will create a node. It's a daemon set that has a node port that listens on port 5555 and allows Docker to connect to localhost, and then is hauled back to the managed Docker registry. So in that configuration, since the traffic is localhost, we don't need to deal with certificate distribution in TLS. So you should see that. It's a forward compatible change. So from 2.2 to 2.3, you'll see as you deploy your applications, the image reference will be localhost :5555 instead of the service IP address for the Deis managed registry. Do note that if you have to go back from 2.3 to 2.2, that you'll need to redeploy your applications to get the appropriate image reference back to the Deis registry, but that shouldn't come into play too much. So no more reprovisioning your Kubernetes cluster because you forgot to add insecure registry. I know I've done that like many times. And also talking about registry support, we've continued to improve private registry support. With 2.3, you may now use exclusively an off-cluster private registry with 3 new configurations. So we've got native support for AWS and ECR with a new component that will do the token refresh behind the scenes. We've got native support for GCR as well, also with short-lived tokens. And then full support for private registries. So if you're using Docker Hub, you're using Quay or Docker Hub Enterprise, you can push all of your images and pull all of your images from that private off-cluster registry. So for new stand-ups, when you install it and you configure it to full off-cluster mode, we won't even deploy the registry into workflow. So we're pretty excited about that, especially the ECR and GCR support, because that's one of the things that a lot of folks have asked for. With respect to Deis Doctor that Jack gave us an update on in the last community meeting, we now have more detailed debugging information when an operator runs Deis Doctor. So that will submit debugging info to the Deis maintainers. You'll get a URL that you can then pass to us, and we can look up that debug information. So that's now included. As well, a number of folks have requested that we deal with the application downtime when doing a workflow upgrade. So in 2.3, we've converted almost all of the Deis components to use deployments themselves. So that the big ones are the router, the registry, and the controller. So 2.2 to 2.3 should be the last upgrade that will take application downtime. Depending on, so 2.3 to 2.4 should be a zero downtime upgrade under many circumstances, at least for the application traffic. Depending on your database configuration, if you're using the on-cluster database, there's still going to be a workflow API downtime as the database recovers, which most people should be familiar with. If you're using full off-cluster Postgres support, then the API will keep on ticking. So zero downtime upgrades, we're pretty excited about that as well. Let's see, last but not least, if for folks who are using multiple process types in their applications, say you've got a web worker and you've got background workers, we now deploy all of those process types in parallel when doing a release. So for folks with multiple process types and large process counts, so like background workers, that should significantly increase the speed of your releases. So that's a quick highlight for 2.3. With respect to 2.4, this came up in chat. We're planning on making deployments the default deploy methodology for all applications. So right now it's opt-in, but that feature flag will flip. So if you haven't had a chance to deploy your apps using deployments, totally kick the tires. We haven't seen any problems with it, but I just wanted to be conservative with the way that we rolled out that functionality. Let's see, I've also published the roadmap for 2.x that currently lives on pull request 417 under the Deis workflow repository. So head on over there, give that a peek. We'd love to see your comments. We'll get that merged shortly. Oh, and then one thing I did forget. We are now, one of the goals that we had with workflow is to componentize the platform and make each of the workflow components usable on their own. I think this is most successfully executed with Deis Router. A lot of folks are starting to use that in Kubernetes clusters on their own. To that end, we are now releasing all of the components individually. So workflow releases are essentially a release of stable releases. So it simplifies our release tooling and what should allow us to ship more focused and targeted releases for each of the components. So you'll start to see that change over time. Not all of the components will be on the exact same version as they go forward. Active components will probably move faster than workflow. Stable components will remain stable. So keep an eye out for that. Let's see. That's all I've got for notes. If anyone has any questions, type it into chat or raise your hand or scream into the microphone. Okay. All right. So the let's see. The next community meeting will actually be September 1st. So we'll see everybody then. Bye.